Hello, everybody. So today I'm gonna continue teaching chapter 3. First, let's make a very quick review on what I taught in this chapter. As I told you last time, guys, uh, uh, we have a number of output devices like 7 segment LEDs, LCD, okay, and we have a number of input devices like switches, push button, keypad, and as I told you, for output devices, the data has to be written from microprocessor to these devices. So this is the direction of the data. Okay, for a switch, for input devices should be the other way. So the microprocessor has to read. Microprocessor has to read these devices. Okay, and as I told you last time, every device input or output has to be connected to a port, as you see here in this picture. Okay, so we have here ports. Some ports we call them input ports, other ports we call them output ports. Okay, you can tell from the name, input ports we connect input devices here, output ports we connect output devices here. Okay, also I told you every port it has like a circuit. Okay, as you see here, this circuit should connect the input output devices to the internal system as it is shown here. Okay, and and also, if you look at this picture, you can see this is our microcontroller. We have a number of ports as shown here. We have port A, port H, port E, and so on as shown here. Okay. One more important thing I told you guys, every port should have number one external pins, and you can see the pins here. So port H, these are the external pin. Okay, for sure. Here in this external pin, we connect input output devices here to these pins. Okay. Also, every port should have two main registers. One is called data direction register. That's what I taught last time. The second one is data register. What is the difference between them? I'm going to tell you what is the difference quickly now. For the data direction register, okay, so again, every port should have data direction register and data register. What is the difference between them? Is the following. Data direction register is used to program or to configure every port, every pin in the port as input or output. That means, okay, that means before, that's what I said, before we use any port, okay, you should configure this port input or output. Okay, so if this port is connected to input device, you have to program it first, input port, or you can have to program it output port. Okay, so the question is, how can we program them? That's very easy. All what you have to do, if you have for a pin, to configure a pin for output, all what you have to do is just write one in the corresponding bit in the data direction register. Okay, so um, so what I want to say is, okay, so for example here, guys, we have here a pin. Okay, it's a port. Every port has a number of pins. Also here we have the data direction register. We call it DDR, data direction register. Okay, every pin here has a corresponding bit here. Every pin here has a corresponding bit here. If I put 0 here in this bit, that means you are configuring this port, this pin input. Okay, if you put here, one, okay, that means you are configuring this pin as output, and so on. Okay, so that's very easy. All what you have to do is you have a register. Okay, and all what you have to do, you need to write ones and zeros in the corresponding bits here to configure this pins input or output. Okay, so there are two questions here. Number one, okay, how many times I have to do this? The answer is only one time. Okay, you have to do this only one time. Usually we do it at the beginning of the program only one time. Okay, once you configure it input, it's going to continue input until you change it. If you don't change it, it's going to continue input or output. Okay, this number two, how can you do it? That's very easy. So that's what I told you last time. We call it data direction register. Okay, but actually it is somehow different from the register we used before, like register A, X, B, and so on. It's somehow different. How it is different? Just they are called register, but when in programming we actually use them as a memory location. That means every register does not have name as we did before. Every register should have like address. Okay, and what you have to do, just put 0 and 1s in this. It's exactly like it's for sure it's not a memory location, but the way we are gonna program it, the way we are gonna use it, exactly like a memory location. Okay, and as I told you, if you look at the memory or the addresses we have, this is as you know, we have 16-bit addresses. That means this is the whole range we have from 000 until FFF, but actually not the whole range are used for memory, as I said. Okay, so the very beginning addresses are used for ports. Okay, so I think I'm very clear on this. So what you have to do is you have to use every instruction we taught for memory location and use it to put ones and zeros this way. Okay. The second part is how I can use the addresses. Should I remember them? We don't like to remember numbers, as you know. Okay. So there is a better way. The better way is, you know, the file that has all constant we use. We always include in our program. This file already, this register already defined in this file. For example, data direction register A for port A, and then equate, and then the address is there. Okay, that means, which is very good, that means you don't need to memorize any addresses. Okay, and we are going to just use English names. Okay, so okay. So what is exactly the exact name of the exact name? The exact name is actually DDR, and then you put here one letter for the the port. So port H, port A, and so on. Okay. So let me show you here in the slides how can we configure ports input or output. Okay, and also I'm gonna I'm gonna explain why. So let me go here. Okay, guys. So, for example, that's exactly what I'm saying here. It's already defined this way in this file. You remember this file? So you can, I post this file on the course website. You can open this file and you can see all the data directions that are defined this way. Okay. So if you see here, guys, I can just use the English name here, but actually don't be confused. This is actually, it's like a memory location address. It's address. Okay. Yes, it is English name, but it's going to be replaced by address. Okay. Anyway, so for example, in this instruction, I'm gonna copy FF to this byte or this register. That means I'm gonna configure everything output because all of them are ones. Here, I'm gonna configure all the pins as input for direction register B and so on. This is for this is here. I put some ones and zeros. So here, the pins that corresponding to zeros are going to become actually input, and the pins that correspond to one are actually output, and so on. Okay. You can also use bit set. You can also use bit clear if you want. Any instruction I taught before for memory location, you can use it now. Okay. So here, I explained also last time why I need, you told us I have to configure. That's true. The question is why? Why I need to do this configuration? Simply because if you look at the circuit here, because when you do the configuration, you do some change in the hardware. Okay, how? As you see here, you connect, for example, if I put 0 here to configure it as input, as you see here, this is switch are going to be connected and these switches are going to be off. That means you are going to connect the circuit this way to make the circuit input. Okay, same thing if I put here 1. Okay, so that means this one is going to become on, this is switch, and this switch is off. By this way, the circuit is going to become this way to make this pin output. So and another point is why they made it this way. They made it this way for flexibility, guys. For example, what if I need all the pins are input, all most of them input, most of them are output? So flexibility. Okay, so any pin can be configured input or output. This is number one. Number two. Okay, now so let me summarize what I said in one sentence. Okay, every port input or output. Okay, before you read or write, okay, to this port, you should configure this port input or output first. How many times? Only one time at the beginning of the program, and I already explained how you should do that. Okay. The other thing here is, okay, I already did configuration. Now I want to read or write from the port. I want to write to the port or read from the port. I want to write some data. I want to read some data. Okay, how I can do that? Okay, very easy. We have a register. Okay, it's called data register. Remember, I told you every port should have two registers. Let me come to the slides. Yeah, here. Every port should have two registers. One for data direction. That's what I already explained. This is just used for configuration. Now, after I configure, now I want to read or write from this. I want to read or write from these ports or pins. Okay. So let me also, as I said last time, here. So here, every pin here is somehow connected to a register. Okay, this register is called data register. Okay, guys. So what's going to happen is the following. If this port is input, okay, and you put 0 here, so the hardware here is going to put 0 logic here, logic 0, okay? Here you put 0 volt, okay? And if you put 5 volt, so this one is going to put 1 here. Okay, let me, one here, okay? For example, let me make it here. For example, if this one is input, for example, okay, and you put here 5 volt, so actually this is done automatically, okay? You don't need to do anything. This hardware, okay? So that means if you want to know if this pin is 0 or 5, all what you have to do is you have only to look at this register, which is a byte. So now you have a byte, and all what you have to do is if this bit is 0, that means the corresponding pin has 0 volt. If this pin is 1, what it means? It means this pin has 5 volt, and so on. Is that okay? Same thing for output. If you have here output, okay, and here we have like a register here, okay. Now this output is connected to some circuit, a motor or whatever, connected to something, okay. Same thing here, guys. If I put here 0 logic 0, okay, so that means there should be 0 volt here. Same thing. If I put here 1 logic 1, so this pin is going to become 5 volt. So if you want to change the volt on one pin from 0 to 5, 5 to 0, whatever you want to do, all what you have to do, we have a register, and we have, for example, every pin has a bit here. Okay. If you write 0 in this bit, you actually put 0 volt on the pin. If you write 1, you actually put 5 volt in the pin. Is that okay? So, and I already taught in chapter 2. I already taught how can you write 1 or 0 in a byte. Okay. So now the question again, the question now is, okay, so how I can do that? So now let me summarize what I said in one sentence. In one sentence, okay, you have a byte. In this byte, every bit is corresponding to one pin. Okay, if you want to put 0 volt on this pin, just put 0 in the corresponding bit. Okay, if you want to put 5 volt on this pin, all what you have to do, you have to put 1 logic 1 in the bit, in the corresponding bit. Okay. Now the question is that, okay, so this is a register, but the same thing, similar to the data direction register. Okay, we call them register, but we are gonna use them like a memory, more in the programming wise. It's gonna be like memory locations in programming. Okay, so it means every data register should have address. Okay, this address usually it is for a byte. Okay, and there should be address. All what you have to do, you have to use the address so that you can write here in this byte 1 or 0, 1 or 0, and so on. And we know how to do that. Okay. So now the question: should I memorize the address? You don't need to memorize it. Okay. So what should I do? All these addresses are defined already in this file. So it's already defined here in this file using equate. So all what you have to do is just use English names. Again, we like more using English names than using numbers. Okay. For example, here, if I say move, So again, here I'm gonna say move 35 to port A. Okay. Actually, don't be confused. Port A is gonna be replaced by address. It's exactly like a memory location. That means I'm gonna write number 35 to the byte that has the address 0. Okay. For sure, when you write 35, what it means? What is 35? 35 means 0, 0, 1, 1, 0, 1, 0, 1, right? So that means this pin, you are gonna write 5 volt on this pin. This pin, you are gonna write 0 volt and so on. Is that okay? For same thing, you can use store A to port B. Okay. Again, don't be confused. This is like a memory location. You're just writing a byte to similar to what we did to memory location. So don't be confused when you see this format. Nothing is new. The new thing here, we use like in a similar instruction I took before for memory location. This one is just address. Port B is just address. Okay. But here I'm not gonna write to memory. I'm gonna write to a port. Okay. So same thing here, you are gonna move something from here to here. Same thing here, I'm gonna read here. For sure, if I write to a port, that means it's output. So this is here, it's output, right? Because I'm gonna write to it. Okay, here I'm gonna store A to this one, so it has to be output. Okay, you cannot read or write from the same port, right? Unless you are dealing with different pins. But here I'm gonna write to this port because this port is output. Here I'm gonna write because this port is output. Here in this case, this is a different case. Okay, here port B is input, so I have to configure before I use this instruction. I have to configure port B as input. Okay, what I'm doing here, this is input because I'm gonna read this port B, and then I'm gonna store it in a memory location. This is just the name of a memory location. So here this instruction may be a little confusing to some students, but I want to make it easy. This one is address, this one is address. We already taught this one before. We already taught we move B, for example, 1000, 2000. We already did this one many times before, right? So it's actually you are copy the byte from one memory location to another. Okay. Same thing here. Load A with port A. So we are gonna read port A, put it in A. Okay. So now the question is that, okay, how I can know this format? The format of the port is here. Okay, the way it's already defined here in this table. You can see, and this is the way they are defined in this file, guys. So here, if you look here, you can see port A, port B, port E. In some ports, we don't use the word port to the complete letters of the word port. Sometimes we just use PT, like for port H here. So you have, this is the way it was defined in this file. So you have to use this format. Okay, guys. So it's not always port, complete port, the word port, and then one letter. It's not always that. In some cases, as you see here, PTT or it's PTB, PTH. There is no reason why they made this way. Just this is how it was defined in the file. And if you want, you can change it in the file. But anyway, you can you can use this format. So instead of just using addresses or numbers, we can use this one. Okay. So anyway, it's just I'm trying to make a very, because I taught this one maybe more than 2 weeks ago. I want to make very quick revision. Also last time, also there's nothing new here. Also last time I taught interfacing with LEDs, and as you see here in the figure, I told you in the port. If you can let me go back here, let me see if I have a picture. I think I have a picture for yeah, it's some here. Where here? Okay. If this is the port here, guys, we have 8 LEDs. Yes, they are here. Look here. Yeah, we have 8 LEDs. Okay, these LEDs are connected to port B. They are connected to port B. Okay, so now I'm going to teach how can we program these LEDs. Okay, so what I explained last time, as you see here, guys, in this picture, we have LEDs. They are connected to pins on port B, as you see here. Look here, guys. It's connected to port B. Okay, and also all the cathodes are connected together, are tied and connected to PG1. You remember what I said? What I said last time? If you put PG1 is going to be used like enable or disable for the 7 segment. What it means? It means if PG1 equal 1, what it means. So if I put here 1, what means I'm going to put here 5 volt, okay? So if you put this 1 in PG1, okay, what it means? It means the LEDs are not working. You disable LEDs. LEDs are disabled, okay? Because as I told you last time, if you put here 5 volt, no matter what you are going to put here, if I put 0 volt or 5 volt, all the LEDs are going to be off. So they are not working, okay? Disable them, okay? Because quickly, as you know, if you have LED, in order to turn the LED on, in order to light the LED, all what you have to, this is the anode. Oops. The anode has to be great, the voltage of the cathode. So the voltage here in the anode has to be greater than this one. So if I put here 5 volt, I put here 0 volt, nothing, 5 volt, nothing. It's not gonna work, okay? Let me see if I have eraser here. I'm sorry. Yeah, I have eraser here. So let me erase something I wrote here. Okay. Now, the other case is, let me change the color. Okay. The other thing is, yeah, now if BG1 equals 0, if I put here 0, okay? So if I put here 0 volt, if you put here 0 volt, so if I want to turn one LED on, all what you have to do, you have to put here 5 volt. So if I put here logic 1, which is 5 volt, so this one is on, okay? If you put here logic 0, which is 0 volt, so this one is going to be off, okay? So that's what I said last time. So let me summarize what I said. What I said here, guys, that we have 8 LEDs. They are connected to port B, as you see here, okay? And we are going to use BG1. What BG1 means? It means port J, pin 1. Okay, that's what it means. Okay? So also, if you remember, so so again, someone can ask me, so always I have when I use always when I use LEDs, should I always use enable and disable? The answer for sure, no. This is the way they design this port, and there is a reason for that. Okay, so for example, you can, if you design your own microcontroller, you can just take this pin, connect it to a LED, and then ground, and that's it. Okay, so if you want to turn it on, put 0. If you want to turn it off, just put 5 volt here. That's it. Okay, for sure you have to put a resistor here, as I told you, to just limit the current. Otherwise, you are going to burn it out. Okay, anyway. Okay, but why they made it this way to make enable or disable? The reason is, look here, guys, port B. Port B is actually, we have only one port B. Okay, this port B is connected actually to 7 segment, to 7 segment displays, 4 of them. 1, 2, 3, 4. So it's connected to 4 7 segment display. It's also connected to the LEDs. That means if you write something here on port B, it should be shown on all of them. These are 4 7 segment displays. Okay, the reason they made it this way, because you remember this port is used for educational purpose, and they made it this way because just they want to put too many things on this port for education. But anyway, so the way we are going to use it is the following: we cannot, only one of them should be on at a time. So we are going to enable only one. Look here, we have 5. We have 5 things connected to port B. Only one of them should work at a time. Is that okay? So how can we do that? Every one of them has like enable bit. So this one has BG1. This one has PP0, as I'm going to explain later. This one has PP1. This one has PP2. This one has PP3. Is that okay? So this is how it works. So at a certain time, only one of them should be enabled. So if I put 0 here, so if you want to use the LEDs, I have to put 0 here in the LEDs, but I have to make sure you have to put 1 here, so that only the LEDs is going to work. Is that okay? If you forget to put 1 here, so actually whatever you are gonna write here is gonna be shown on all of them, okay? And for sure, for 7 segment, it's gonna look like messy, or you cannot see like a character or letter or a number, whatever. Okay, so if I want to use this 7 segment, so I have to put 0 here and 1 everywhere, and so on. This is the way they make it. Okay, now. Okay. Now the next program I taught last time, guys, how to make a flashing LED. And the flashing LED means I want to turn it on for 1 second, off for 1 second, on for 1 second, off for 1 second. And this is the steps you have to do. For sure, I need to configure pin 0 on port B. I want to configure it as output. Also, you have to configure BG1 because these are the 2 pins I'm going to use. So you have to configure these 2 pins as output. Also, as I have just mentioned right now, you have to disable the 7 segment. Okay, this should be done only 1 time or at the beginning of your program, and then you have to pull BG1 pin low. Why it has to be low? Just one pin. You have to put 0 in this pin. Okay, why? This is because you have to enable LEDs. Okay, and then after that, I'm gonna pull BB0 pin high. So that means I'm gonna turn the LED on. Then I have to wait 1 second. Then I'm gonna turn it off. I'm gonna wait 1 second, and then I'm gonna go back to here. Can see, guys? So I'm gonna keep repeating this part. Okay, turn on, wait 1 second, turn off, wait 1 second, go again, turn on. So if you look at the pin, if you connect this pin to the to the scope, to oscilloscope, you will see a signal like this one. It's 5 volt for 1 second, 0 volt for 1 second, and so on. And I'm gonna show a picture here. I connected, yeah, that's what I did. So you can, if you look at here, this is 1 second, 1 second. So you actually, what you are doing, actually, you are actually generating a square wave. Very easy way to generate a square wave. And this what is gonna be the coming lab is about. The coming lab is gonna be about how can you generate a square wave, okay, with different duty cycle and so on. Okay, so here I just pull it low, wait 1 second, and then put it high, pull it high. So let's see the program here. That's what I said here. This is the configuration part, should be done only 1 time, as I said, guys. So here you have to configure BG1 output. Okay, so bit set here, it's number 2, guys, because I want to configure BG1. Remember, BG1, it doesn't mean the first, it means the second pin. Is that okay? Because we start counting from 0. So this is 02 means 0, 0, 0, 0. It means 0, 0, 1, 0. That means you wanna configure a second bit or second pin here. Okay, and then after that I clear this pin. So here this part is just a configuration. Okay, for output. The second part here is you actually, I'm gonna write 0. I'm gonna write 0 on this on this pin, okay, to enable the LEDs. These 2 instructions I'm gonna talk later about them, but as I just explained right now here, I told you we are gonna use PP0 all the way to PP3 to configure, to enable or disable 1. So I use 1 for each 7 segment. So 1 for each 7 segment. Okay. So here, if you see here, I'm gonna put 1, 1, 1 in the first 4. I'm gonna write 1, 1, 1 because I want to disable all of them. Okay. So here I don't care about. I only care about the first 4 pins. Okay. I don't care about the others. Okay. And then here. For sure, I have also to configure port B as input. So here I can use bit set to configure only one pin. Okay, and this configuration, it should be done only 1 time. The other part here, guys, here, this is the program. I'm gonna turn the LED on, and that's very easy. We did this many times in chapter 2. Just you have a byte. How can you how can you write 1 or 0, and then we're going to use these two instructions. I'm going to explain them right now. To wait 1 second. So here I'm gonna turn high or pull the pin high. I'm gonna wait 1 second, and then I'm gonna come here. I'm gonna pull it low. Wait 1 second, and then I have to come back and repeat again. Okay. So this is how it works. So before I forget, on the course website, guys, all these programs, you have all these programs, and this is the name. You can download all these files. You can download all these files from the course website. So this is the name of this program. Okay, and you already have the board. I'm quite sure the programs I post on the website are working. So you can play with this program. You can run this program, and then you can play in the time and so on. Okay. Also, what I explain here, guys, about the time, how can you make a delay? The way we are gonna make a delay, we created a function. This function is called delay y miss. Okay. So what this function is doing, this function is gonna make a delay for y millisecond. What is y? Register y. So that means if I put in register y 5, number 5, that means I'm going to make a delay for 5 milliseconds. If I put in register y before I call this function 1000, like this case here, this is the case. So register y, I'm going to put 1000, okay? And then I'm going to call this function. So that means I'm going to wait 1000 milliseconds, which is 1 second. You understand what I'm saying? So before you call the function, you have to set register y first, okay, with how much delay you want. Okay, guys, so let me say it again. We have a function. This function is called delay y millisecond. Okay. Before you call this function, you have to put a number in y, and this number should be like how much delay in millisecond. Is that okay? Now, this is a subroutine here, or the function here. This is how the function works. This is the main idea of this function. Okay. Again, until now I didn't explain anything new. I'm just making because I told this one long time ago, so I want to repeat it again because I'm gonna build on what I did here. So it's very important. So nothing is new so far. Okay, so. How this function works, guys, as you see here, guys, the idea is that I want to make y millisecond delay. Okay, so the idea is that I'm gonna execute some instruction. Okay, this instruction actually are not doing anything. Just I want to waste, because as I explained in chapter 2, every instruction takes some time, some execution time. Okay, so for example, this push A, pull A, push A, pull A. What you are doing? Nothing. I just push, pull, push, pull. I'm just wasting time. Okay, because push is gonna take 2 cycles. Pull is gonna take 3 cycles. Okay, so if I can make from here to here, as you see here, guys, I can make 24 cycles. So to execute this instruction from here to here, I need 24 cycles. Okay, and as we know, our clock is our clock is 24 megahertz. That means every cycle is 1/24 microsecond. Okay, so this is every cycle. So that means 24 cycles means 1 microsecond, and that's true. So from to here, guys, it is actually one microsecond from here to here. Is that okay? So from here to here, it is 1 microsecond. So if I repeat this part 1,000 times, so I can make 1 millisecond. That's exactly what I did. If you see here, guys, so here I'm gonna make a loop for 1,000 times, because I'm gonna repeat this part. This part again from here to here is gonna take 1 microsecond to execute this part. This part I'm gonna repeat it 1,000 times because I created a loop here. You can see I created a loop. So that means from here to here we can make 1 millisecond. So this is 1 millisecond. From here to here it's gonna be 1 millisecond. Okay. Now how I can make? Remember, I want to make y millisecond. So now this part is going to be 1 millisecond. So in order to make y millisecond, so I have to repeat this part y times. That's exactly what I did. If you look, we have another loop here, guys. I'm gonna loop to here. Okay. I'm gonna loop to here in order to in order to repeat this part, I'm gonna repeat this part y times. Okay, so whatever in y. So let me tell you the conclusion. The conclusion is we have a function, we have a subroutine. This subroutine is called delay y millisecond. This subroutine should make a delay. This delay should be for y millisecond. Before you call this function, you should set y. So you have to write in y how much delay you need in millisecond. Is that okay? So we have another function. It's the same idea, exactly same idea. It's called delay y microsecond. It's not y millisecond, y microsecond. It's exactly the same idea, guys. But here I'm gonna this part. I know this part from to here is gonna take 1 microsecond, and then I'm gonna repeat this part for y times. So it's exactly the same idea, similar to this one, but this one here, if you see here, I created a loop for 1000 because in order to make, so this one is 1 microsecond, and then I'm gonna loop here 1000 times to make 1 millisecond. Okay. Here I'm gonna loop y times here on this part, and this part is gonna take one microsecond. Is that okay, guys? Okay. Now, so and this is a very important thing, guys. We have in this chapter and next chapter, we have a number of subroutines written in assembly. Okay, I already explained 2 of these subroutine: delay y in millisecond. I also delay y microsecond. Okay, we have more subroutines. Okay, in order to make programming easy, what I did, I collected all these subroutines. I put them in a file. This file is called subroutine. Sorry. This file is called subroutine.include. Okay, you will find this file on the course website with the programs. Okay, so you can find this file. So just to make programming easier, you don't need to copy and paste the subroutines. Okay, let me say it again. I'm gonna teach many function just to make programming easier. Instead of you just copy and paste the functions we have, I put all the function in one file, and all what you have to do in your program, you have to include this file. That's it. And then you can use all the subroutines. You don't need to worry about it. You don't need to copy and paste, just to include the file. Okay. So the way you have to include the file is, guys, remember we have here org 4000. Is that okay? And then you have your code here, your program. It has to be here. After you finish your program, you have to write the instruction include we did before. Okay, you have to write the instruction include similar exactly. Remember, we have here org 1000. And we have another include here, remember. So here your program, we should have 2 includes. Include here, but this include for which file? The file we include from the beginning of the semester, from the beginning of semester, this file. That's what we already did. It's not something new, okay? So we already include this file. But what I want to say is, now we are going to include 2 files. We're going to include this file as usual, as we have done before in the beginning, but we're going to include another file, which is called here subroutine.inc. Okay, so you should include it here. And why this one has to be here and why this one has to be here? Simply because, okay, that's very important, because you remember when you include a file, actually what's going to happen, this instruction is going to be replaced by the content of the file. So it's similar as if you copy the content of the file and put them here. Okay, so, and because this file, this subroutine, this file here, this file, it has instruction, so I have to put it in the location of the instruction, which is here. Okay, but this file has equate. So it has this instruction equate, and we have to write equate here in the beginning of the program. That's why I put the file here. Okay, guys, that's very important, guys. If you change, it's not gonna work. Okay, again, this file has instruction, so I have to write in the instruction area here at the end. Okay, at the very end. Also, the other file here we included before, it has equate, and equate has to be here. Okay.